Welcome to Spaceverse, your portal to cosmic adventures. These are the first James Webb Space Telescope observations of tidal disruption events, and they look nothing like anything astronomers have ever seen before. The universe can be beautiful, mysterious, and absolutely brutal. Somewhere out there, in the dark hearts of distant galaxies, stars are being torn to shreds by invisible monsters, supermassive black holes. And for the first time ever, the James Webb Space Telescope has captured the cosmic carnage in extraordinary detail. Astronomers have turned JWST's powerful infrared eyes towards some of the most violent scenes in the cosmos. Stars being ripped apart and devoured by black holes. What they found was astonishing. The black holes responsible for these stellar murders weren't the usual active, raging ones blasting energy across their galaxies. Instead, these were quiet, hidden giants, sleeping in dusty galaxies, waiting patiently for an unlucky star to wander too close. Using JWST, a team of researchers focused on several of these so-called tidal disruption events, or TDEs. In simple terms, a TD happens when a star strays too close to a supermassive black hole. The black hole's immense gravity grabs hold of the star, tears it apart, and releases a tremendous burst of energy. Since the first TDE was spotted in the 1990s by the X-ray Rosette All-Sky Survey, astronomers have identified around 100 such events. But JWST's view adds a completely new layer to the story, because it can peer through dust and gas that would normally hide these cosmic tragedies from view. And that's exactly what's so exciting about this discovery. These new observations suggest that TDEs might actually be far more common than we thought, just happening in galaxies cloaked in thick dust, invisible to our optical telescopes. These are the first JWST observations of TDEs, and they look nothing like what we've ever seen before, said Megan Masterson, the study's lead researcher from MIT. We've learned these are indeed powered by black hole accretion, and they don't look like environments around normal active black holes. The fact that we are now able to study what that dormant black hole environment actually looks like is an exciting aspect. So, how exactly does a supermassive black hole hide its violent feeding habits? Let's break it down. A tidal disruption event begins when a star's orbit brings it dangerously close to a supermassive black hole, one with a mass millions or even billions of times greater than our Sun. That immense mass creates a gravitational force so powerful that it literally pulls the star apart. The process is as dramatic as it sounds. The star gets squeezed horizontally and stretched vertically, a process scientists like to call spaghettification. Picture the star being stretched into a long noodle of plasma and gas. But this cosmic spaghetti doesn't fall straight into the black hole. Instead, the shredded material forms a glowing disk around it, known as an accretion disk. This disk swirls at incredible speeds, heating up as it rubs against itself and producing a brilliant flash of light, one so bright it can outshine the entire galaxy for a short period of time. But that's not all. Some of the star's material doesn't make it into the black hole at all. Instead, it gets funneled toward the poles and blasted outwards as jets of radiation and high-energy particles moving close to the speed of light. These jets send a signature that astronomers can detect across multiple wavelengths, from visible light to X-rays. Now here's where things get tricky. Most of the TDEs we've detected so far occur in galaxies that are relatively clear of dust and gas. That makes them easier to spot. But in dusty, gas-filled galaxies, that same light is absorbed before it ever reaches us. Dust acts like a cosmic curtain, blocking optical and X-ray light. But there's one kind of light that can slip through, infrared, and that's where JWST comes in. The James Webb Space Telescope is the most powerful infrared observatory ever built. Its detectors can see the faint heat signatures of stars and galaxies hidden behind walls of dust that would completely obscure them from other telescopes. So, Masterson's team decided to put JWST to the test. They pointed the $10 billion telescope at 4 galaxies cloaked in thick dust where TDEs were suspected to have taken place. And sure enough, JWST found what they were looking for. In these galaxies, the telescope detected infrared fingerprints of supermassive black holes devouring stars. Think of it like a cosmic crime scene. The black hole is the suspect, the shredded star is the victim, and the glowing infrared emissions are the telltale evidence left behind. To confirm what they were seeing, the team looked for a very specific infrared signal, one that can only come from a black hole that's actively feeding. This signal appears when the radiation from a black hole's accretion disk strips electrons from nearby atoms, ionizing them. One element in particular gives off a unique fingerprint when this happens: neon. When neon atoms are ionized near a black hole, they release infrared light at a specific wavelength, and JWST can detect it perfectly. There's nothing else in the universe that can excite this gas to these energies, except for black hole accretion, Masterson explained. Out of 12 dusty galaxies the team investigated, JWST found this neon fingerprint in 4 of them, solid confirmation of TDEs taking place. One of those galaxies hosts the closest TDE ever detected, just 130 million light-years from Earth, practically next door on cosmic scales. But confirming that these black holes were feeding was only the first part of the mystery. The next step was figuring out whether these black holes are always active, constantly devouring matter, or if they were dormant giants that only wake up when an unlucky star drifts into their gravitational grip. The answer was surprising. By studying the distribution of dust around these black holes, JWST found that they look nothing like the environments around active galaxies. In active galaxies, supermassive black holes are usually surrounded by thick, donut-shaped clouds of dust and gas that constantly feed them. But in these 4 galaxies, the dust was arranged very differently, more chaotic, less structured, and not consistent with an always hungry black hole. That means these black holes were likely sleeping, lying in wait, until a star wandered too close. When that happened, they woke up, ripped the star apart, and went back to slumber once the meal was over. Together, these observations say the only thing these flares could be are TDEs, Masterson said. The implications of this discovery are huge. It suggests that our universe might be teeming with hidden tidal disruption events, happening behind curtains of dust in galaxies we've barely glimpsed. For every TDE we've detected in visible light, there could be many more concealed in the infrared. This new window opened by JWST could help astronomers piece together one of the most fascinating puzzles in astrophysics: how black holes grow and evolve over time. The next big goal is to find and study more of these dusty, obscured TDEs. Each new detection could help scientists understand how much stellar material black holes actually consume and how much they spit out. It could also reveal how long these violent feeding episodes last. After all, devouring a star isn't quick. The actual process of a black hole gobbling down all that stellar material takes a long time, Masterson explained. It's not an instantaneous process, and hopefully we can start to probe how long that process takes and what that environment looks like. No one knows because we just started discovering and studying these events. Think about that for a moment. Humanity is only now beginning to watch in real time as black holes dine on stars. The James Webb Space Telescope, with its unmatched infrared sensitivity, has become our cosmic witness to some of the most extreme events in existence. Events that shape galaxies, influence cosmic evolution, and remind us of just how powerful and mysterious black holes truly are. From the outside, these galaxies may look peaceful, faint glows of dust and light drifting in the dark. But deep inside, hidden by cosmic veils, titanic forces are at work, twisting spacetime itself and transforming stars into streams of gas spiraling into oblivion. It's a haunting thought, and a thrilling one. Every TDE JWST observes is not just a glimpse into destruction, but a key to understanding how the universe recycles itself. Stars die, black holes feed, galaxies evolve, and the cycle continues. And that wraps up today's journey into the dark hearts of galaxies, where even destruction becomes a kind of cosmic art. The James Webb Space Telescope has once again pulled back the curtain on the universe's hidden drama, revealing that black holes don't just consume stars, they reshape galaxies, recycle matter, and keep the cosmos in motion. If you enjoyed diving into this stellar mystery, don't forget to like, subscribe, and share this video with your fellow space enthusiasts. Every click helps Spaceverse continue exploring the most mind-bending discoveries from across the universe. Until next time, keep your eyes on the stars, because somewhere out there, another cosmic story is just beginning. This is Spaceverse, where the universe is never out of reach.